Mongo I particularly like. I think it's a good company. It's also doing quite well. If you look at the stock of that company, it's an open company, public company, and the stock has actually done quite well. So 2 years ago, when I first began looking at Mongo, their stock was at, I think I bought stock for like 30, I think it's like $39, like $40 for stock. And now if you look at their stock, it's gone up to like 200 and something, which suggests that it's not just the stock price here that's good, but it suggests that the public is actually becoming much more interested in these kinds of databases. And so when I was choosing a database for this course, I looked at the stock prices of some of the systems that I was looking at and some of the services. And if I saw that those stock prices were going up, then that was to me enough to tell me that actually there was some public buy-in to these. It means that they're not just, they're not pieces of software or or tools that are just going to fade away into the night, but actually they're here to stay. And so I think that Mongo is actually here to stay for quite some time. And I'll tell you why that is. Um, when we, to start off with, when we were working with our SQL databases, one of the problems, if you can call it a problem, I know that it's a good database, it does some pretty good stuff, but one of the main problems that I claim is with SQL is that every time you want to keep track of some kind of data, you really have to have a table. Now that's important, and we accept that. We've spent like a whole bunch of time here, actually developing different tables to accommodate our data. And so we create, let's say, this table here where we have first name, last name, primary address. Let's just say that that's the information that we need right now. And so we create the schema to accommodate that information. Now, let's say that later on, we decide that actually we need not just primary address, but we also need like the secondary address. And so we have to go back to our table and redesign it. We have to create the new schema for that table. And while that's okay, and we don't mind doing that, it's still kind of annoying though, because we have to go back to our code and change the actual foundations of our database. Now, this is just one table. Imagine now if you have like a much richer database where you have many different tables all coming together. You may have to actually go through and reestablish other tables and then reestablish other types of relationships and so on. And that's all when the information that we collect, that changes. So we need to kind of continually update the foundations of our database. So again, let's say that we update our database again when we have, like, for instance, we had primary address, the secondary address, and now we have the third type of address. Again, we have to go back and change. And I think you get the idea here that each time you have a new kind of data that you're going after, you have to change your database. Now, let me just say something here. That is that this is, it's actually essential for you and your company to be able to respond to the data needs you have. Companies survive on the waves of data, and if that data wave crashes on top of you, then you sink. And so what I'm saying is that you have to be able to keep up with the data that you're actually that you're interested in using. And so there should never be the case where you cannot collect the data or you cannot do something because your software prevents you from doing that. That is a big no-no. That's actually very, very dangerous. And many companies back in the dot-com era, back in the year 2000, actually Amazon was a dot-com. But these were companies that started out on the internet when it first began to get big, and they were doing. I mean, they had all kinds of different deliverables and products that they were selling. But the thing is, there that many of them were unable to keep up because of their database. I mean, believe that just for a second. The databases were so unable to be maintained and kept up with the new information that they had to keep in order to make their data, or in order to make their business or their relevance more pronounced. And so they had this trouble where they had to continually go back to their databases and then redesign it. And maybe they were able to design it correctly each time, and maybe they didn't. And many companies were not able to redesign their companies or their data collection systems. And they eventually went out of business because their competitors were able. And so the thing is, though, that you're always redesigning your database no matter what. And you should never have your database should never stand between you and opportunities that you're trying to go after in the business world. Anyway, I'm kind of digressing here, but the expectations are that when you create these extra tables in your schema, that they're going to get filled up, that everything's going to work according to plan, that everything's going to be there. You're going to have all the stuff that you need: the first name, last name, primary address, second address, third address. All that information will be there, perfectly stored for you. and it will be easy for you to search and get to. Um, However, that's just an expectation, because in reality, what happens is that your tables uh, tend to not get filled up all the way, and so you basically have a bunch of space in these tables that you have to work with, and that makes a very bloated table. And actually, if you think about the amount of memory, just the hardware memory that you need to have to run such a table, that could be very taxing, because you have these giant tables where you've allotted all this space for each entry, and if no entry is there, then that space is more or less wasted. So it's just kind of like this table is sitting there in memory, and there isn't much data in there. And so then you have to start getting more and more. You have hardware problems because you're trying to figure out ways of of getting to the data that you do have amongst the data that you do not have, or amongst the empty space that you do not have. And so what I'm trying to say is that it gets hard to manage all this stuff here. It gets very, very difficult to manage these giant databases. Now think for a second here where we're going. We are going to the internet, where most of the companies that we work with are online. They're online, and the information that comes in one year may be completely different from the information that came in the previous year. I mean, imagine if you were Facebook. Not that I'm trying to push Facebook on you, but if you imagine when Facebook first came out, the type of data that they thought that they needed was they had pokes back then, and they had like status reports. Um, I think they had like personal information, maybe a few photos, but now it's like a bunch of extra stuff too. There's metadata, there's location data, there's connections to all your other friends that you have, and then there's the connection to those friends, and also there's algorithms that are trying to figure out whether you know somebody through somebody else, kind of like a second degree type of separation network where you may know the friends of your friend. And so all that is data that has to be stored someplace. And so the trouble is that when Facebook was first being started, they probably didn't know that that information would actually be there to have to or to worry about. They didn't realize that that would be something that they would need for their company. And so they may have had this problem here where they created a table. Actually, they didn't have this problem after for they changed their tune, and later on in this class I'll tell you why. But they did not. But they had to. They still had to. They still had to change some of their tables around to accommodate this new information. So we ask ourselves, okay, so if we're a company online and we're collecting data and we don't know what that data is going to be, like in the next year, and so we may have to go back to our database. Should we be thinking about buying more developers or paying more developers to redesign our database system and putting us offline for a moment while that database is being tested and reinstated? Or do we use a different type of database system entirely? And so we decide that we're going to use a different type of database system entirely, which doesn't need tabled schemas like what we were talking about before. In other words, the data comes in, and as it's coming in, the database will look at this and say, oh, I see this is a name piece of information, or this is a last name piece, or this is some kind of data that concerns some miscellaneous thing. So I'll just go ahead and store this here. So what I'm saying is that this database that we're about to talk about now doesn't use a schema, but rather it figures out that schema as the information is being poured into it. So it uses up a little bit more memory, but that's okay though, because in the long run, you don't have to worry about redesigning your system. Whatever you had last year should still work this year, and it should still work next year without having to worry about too much change. So we're going to be talking about something called the MongoDB, which is what they call a NoSQL. And the N and the O in NoSQL stands for not only SQL. It's a system that runs just like an SQL database, but the difference is though that it's much more convenient for what they call volatile data. That means the data that comes in may not necessarily be known when you design this database. However, it does allow you to store that information, and you can hold on to it. So I'll just read this here. A database system that supports SQL-like queries. So in other words, the stuff that we have already learned about databases from SQLite, that still applies here. All that stuff that we've learned before still applies here. We are still able to get to our data. We can still run queries. We can still store data. We can populate things. We can connect things. We can harvest information from different tables, and we can actually isolate specific types of patterns that we'd like to find in the data. That's all possible. That's just a matter of writing queries. The difference, though, is that we can use our applications now are becoming increasingly big in data, and we have what they call real-time web application capabilities, which means that we can just make this database, hook it up to our web server, and when people log in, whatever data they give us is absolutely fine. We can go ahead and grab that information. Now, this is what their website looks like. I will tell you, actually, let me just go. Every time I click on links here, I end up losing my slides. Let's go ahead and put this back in here. Right, so I wanted to take you through their website. I mean, it is worth reading their website, I think, because they do have some pretty good customer support. They do have a community version of the software, so you don't have to pay for it. So it's a free system, and the company actually makes their money by consulting companies and businesses, kind of teaching them, training them how to use their software for their particular applications. But for us, though, we can get a community version of the software and still run it just as we would with SQL. But these are some other big companies that they work with: Google, Adobe, eBay, eHarmony, EA Games, Squarespace, even Sega. All of these companies actually use MongoDB in some way. Now, let me just take a second here and look at these companies. Look at a company like eBay. eBay sells things. It has really no idea what it's going to be selling because that depends on the users who log in and submit their work, or they submit their products or whatever they're selling. And then eBay then figures out how to order that information and then put it out to the rest of the crowd, the people who log in. So the thing is that eBay, you could see, would be one of those companies that would continually have a problem like this, where their database would have to be continually changed depending on the kinds of businesses that they're offering online. And so it does become this actually a very good solution for these kinds of companies. The other companies that we saw on their websites tend to have similar kinds of applications, I would argue, where the data changes from year to year. Like, for instance, we saw what was it, EA Games, Google, for instance. All of these companies are changing the types of information that they give out. EA Games, particularly, because I mean they make video games, and so maybe the games they require different types of tables to keep track of parts of the game. I mean, games are diverse. Anyway, I think you get the idea there. And so this MongoDB, though, actually does kind of handle those applications quite well because, well, you don't have to go back and redesign the database each time. Now, before we get to the actual database, let me just take a moment to give you some new vocabulary. This is one thing that I always find fault with whenever I'm reading about databases, and that is that every database has different vocabulary. They always do. They always call things, the same thing is called something different across each database. The database itself, this is your relational database management system, your RDBMS. That's like your SQL Lite that we just saw. They call them databases. And here in MongoDB, we also call it a database. However, things get different here because SQL called it a table and a view, which is kind of when you search on something, you saw your data actually in a kind of a table form. That's what a view is. Your table and view are actually now called collections. Collection, like kind of seems like a piece of poetry, doesn't it? Like the collection. It seems like some poetic name, but it's called a collection. And so when you're asking somebody to show you the entire contents in a table in MongoDB, you should change the sentence and say, please show me the entire collection in MongoDB for that particular data or in that database. And so the collection. Then we have this other thing I found very hard to swallow, but rows. Each table has a row. There's column and rows in SQL. But rows now will be called the documents in MongoDB. And so a document really means like the entire record that pertains to some part of the entire record, I guess, where everything is connected with some relation. So your collection of data in Mongo is going to be a series of kind of records where you have maybe a person, you have their address, their phone number, their email account, all that stuff. And so that whole row, as we'd call it, is now going to be called a document. So you may have a database which contains several different documents for each person that you actually have listed in your database document. Then you have, for instance, what we call columns. You'd call those fields. That is because you don't have the notion of tables doesn't exist anymore. You're just having kind of a big kind of JSON file that's like filled up with all kinds of stuff. And so the notion of a column is no longer a column, it's more of a field or just a place where you can put information. Then you have indexes. We didn't really talk about indexes very much here, but those are the same. You have joins. We did talk about, we call them now embedded documents, where you're actually kind of like mixing two things together. We talked about foreign keys. Those are now called references. So they serve the same purpose. It's like they do the same thing. They just have different names. I don't know why they had to change it. Another thing that's kind of interesting though is called a partition. A partition is a kind of a specific area of data that we're looking at. Maybe after our query, we'd write we'd write a query to actually give us a specific piece of the table. That's what we'd call a partition. I mean, there's other stuff involved too, but really a partition is a piece of the whole table. But in MongoDB, they call that a shard. A shard, like a shard of glass, where it's a piece of the whole. There's like a piece that would have come together, would have come up with other pieces to make the whole. So the terms are different here, but actually their meanings are very, very similar. And the code that you would, or the thinking behind the code that you'd have to actually locate these particular pieces of information are very similar. So it's not like you have to change. You don't have to change your thinking. You do have to change the code that you type in. The code is not going to be the same. But I'd like to say though that it's like you don't have to change the logical, I guess the means or the way of thinking about how you pull the information out. But one thing though that's most important about this is that this whole MongoDB system is called a schema-less configuration, where you have no schema, there's no table, you don't have to worry about, you don't have to know what the data looks like before it comes to you. In other words, you just pipe it into SQL, or sorry, to Mongo, and then Mongo will then take care of the actual organization for you. So they call that the schema-free. Now, it does take some time. You should take some time though to really kind of look at the way that the data is organized. But I think though that once you've looked at it for, I don't know, a short while, you'll get the idea of kind of like how the data comes together. And so here we are. We have multiple collections here. Remember your collections; those are like your table views here. So these are your table views, and so in each collection here, I have the name Al, who is his age is or her name, it's Allison. Her name is 18. Her status is D, and her groups are politics and news. And so, for instance, these may be student types of logins here, where status is like when she's going to be taking her test, and the groups that she has are maybe politics and news. Maybe that's her research interests or something. And so you can see that these pieces of information are kind of like established after the actual information, the strings that we're using here. So now I will say one thing though, and that is that the name, the age, the status, and the groups, that does look to be a schema. But the thing is though that that's a schema, which is actually, those are actually the variables that you might use if you're writing code that asks the person for their name. You say, what is your name? And then your input would go into this variable called name. What is your age? 18. Your input would go into this variable called age. And so you do have to guide the schema in a certain way, but it's not like you have to create the tables though, and worry about the varchar and tell it whether it's a specific, if it's a string, or whether it's a floating point, or whether it's a scientific notation number. You just kind of like throw this information together into this. This is called a JSON file. That's what it looks like. You have these two curly braces at the top and the bottom, and then you have names. You have these names of variables in which you're going to be using to hold particular pieces of information. Now, name here, that is going to be a string. Age, you can see this. That's an integer. Status, that's a character or a string. And then we have groups, and groups here is an array. And so we do have the ability now to use not just strings as we as well, we can use not just strings as we might think, but actually that we can use numbers, strings, characters, arrays to hold our data, which is something that we had before when we were working with our Python code for SQL. We were actually able to use these kinds of I guess, data structures. So what I'm saying is that you do have data structures in your at your command. But one thing though is that it's kind of interesting though is that this is a series of collections. This is different data for let's say a project that I'm working on. But let's just say that I have a questionnaire that's going out where I'm asking people to fill in information about their name, their eye color, their birthplace, aliases, locations, and their boss. Now, when you put information out, or when you put out a questionnaire or a survey where you're asking people to fill in this information, you may not get information back. You may not get all the information that you want. So here what we have is you can see that there's names. Everyone put their name in here, but some people filled in their eye color, some people didn't. Some people put in, for instance, their favorite type of pizza. Only one person, Matt DeGorno here, put in his, Matt put in his favorite pizza, DeGorno. Then we have height, we have location. So what I'm saying is that we don't have all the information in each of these. The information isn't all the same here. But to MongoDB, that doesn't matter. You just give the information to Mongo, and it will create a collection out of whatever you want here. And so this is basically this. It's like creating whatever information you give it. It's making one of these. I guess like if you think about it as an index card, it's basically putting all that information onto one index card. And the nice thing about here, though, is that once the information is in these collections, you're now able to do some queries. And if the information exists, then you can pull it out. But if it doesn't, then it just moves on to the next collection. And so there's no big thing. So the query interprets missing data as null entries. And so you don't have that not null necessarily, or that not null keyword that we used before. We have, because you're not always going to have information in some of these things here. So if it's missing, it's just null. So it's always best to leave it as null. But that's okay though, because it doesn't affect your query at all. Your query will just go through each of these collections, and where it finds a name, it will give you the name. Where it finds, for instance, the birthplace, it will give you the birthplace. Where it finds, for instance, the pizza name, it will give you the pizza name. But if it doesn't find that in one of the collections, then it's no big thing. Okay, so I just want to take you through kind of the what the what it looks like here to when you're when you're actually working with your your queries. But they call this the name value pair system. That's really how the queries work. Where, for instance, here we have name, which is our kind of our variable, and that variable would be found inside here someplace, inside one of your collections. So in this case, name would be Will. But here, actually, name is not Will. Name is actually equal to R2D2. So this colon that separates these two pieces here is kind of your connector. It's your mini relationship. So here we have name, and here we have R2D2. And so this tells me that if this were a whole collection right here, where this from this piece to this piece, and that could be a collection, then the information I have here is name is equal to R2D2. Now, you can actually separate your data by commas when you're putting together your collections. As we saw here, each piece of information is actually collected or separated by a comma. So the more information you have, the more commas you have. And it's no big thing. Mongo doesn't care how many commas you have in here. And so here what we do is we're creating, again, we have name, but we have more information too, where we have a race character, which is what kind of robot this thing is. It's a droid. And so we're actually able to kind of like spread out all our information just between commas in this collection. Now we can even add more information that we want. So for instance, we can have the name, we can have the race of the droid, we can have the affiliation. He's one of the rebels. And for instance, if you wanted to add more information here, you just have to put another comma between each of these new things. Now notice though that this is a perfectly working schema. It's a schema. it holds the information and Mongo can get to it, which means that if I write a query, and I'll show you how to do the queries in just a moment, but I can actually do a query and say, give me all the names of all the stuff that's inside this collection. It would say, okay, this is a name. Okay, so I'll give you this information here. And it would check here. Is that all? Is that a name? No. Is this a name? Nope, that's not a name. And so it would just say, well, this is what I found in terms of name. And so then it would just give me, it would return to me this information. You can also have array information stored inside brackets, which means that, for instance, you might want to have, I don't know, collections of different types of information in connection with this, in connection with this collection here. So what I'm saying is you may have other information that you'd like to keep kind of together. And so here, you see that the name, the race, the affiliation is there, but then we have this comma here. And so now we're saying that this information here is more information, which I would like to keep together with this information here. In other words, I'm saying that name Yoda and the Yoda's affiliation is now its own relationship. So what you're seeing here is that you're still creating relationships between data, as we saw before. But here, our relationship is that we're able to kind of tie things together using a colon or by having commas and curly brackets. Now, this might just seem kind of complicated here, but I think that once we spend some time actually running some code here, then we'll get an idea about how the data comes together. But just bear with me for a second. Now, we have what's called the Crud operations. Now, every single database, in order to have any value as a database, must be able to create data, read data, update data, and to delete data. So we call those the Crud operations. C for create, R for read, U for update, and D for delete. We saw that in SQL. We were able to insert data, which is our create. We were able to read data, which was our query. We were able to update, which was our amend things. We were alter data, that was the update. And we could delete data by just typing in drop. So in other words, we are able to do all of these things as we were before with Mongo. So that means that all Mongo has this, I mean, Mongo does have this, it has the same qualities that SQL has. Every database has these qualities, otherwise it wouldn't be a database. So these are some of the commands that you'd use. And while it does take some time to swallow some of these things, I will say that when I first saw some of these commands here, I thought, how will I ever remember these things? But actually, if you remember that when you're typing your queries, you begin by typing db dot, and then over here, collection. Collection, that's the name of the table. That's the name of this piece over here. That's your table name. The table name. So you type in db, that means kind of like get the attention of the database. Then type in dot, table name, dot, and then you have your insert command, or you have your save command, or you have your update command. And those are all commands you'd use for creating data or adding information to your collection. So collection here is the name of the table that you're working with. And we'll talk about that in just a moment here. When you're reading something here, it's exactly the same. That means if you're running a query, where, for instance, again, you have to type in db, and then the collection would be the name of the table that you're going after. I'll call them tables for now, but they're really not supposed to be called tables. They're supposed to be called collections, but you get the idea. And then if you want to find information, you have this .find command. And it's the stuff that goes inside here which actually creates a query. So you're actually able to kind of like to look for, create code here to look for specific pieces of information. Then you have this other find command here that says find one. It means basically you're looking to see whether there's at least one case of something you're looking for. In that case, I guess you might have a colossal database where you just need to know whether some name is in there, and you might run this. So, for instance, you might use this to determine whether there's any overlapping information, whether someone's name is listed twice. Who knows? You could run a quick test like this. Say, is this name already in the database? If so, then go back to the user and ask them for a new name. But there's many other possibilities. Then we have this update command, which is when you save something to the database, you have to kind of commit those changes, and then you have to kind of review everything here, or you update everything. So that means you get an updated version of what the database is now doing. And then we have this remove or delete command here. So if I wanted to remove data or to take out a table or something, then I could run, actually this wouldn't be for removing tables, this is for removing data. The actual command to remove tables is just drop, as we saw before with SQL. But what this thing does though is it allows us to actually change data. So where am I going with this? Well, I'm saying that every database that we cover here, every single database will have these CRUD operations. I hate that word CRUD. I mean, CRUD. But every database, though, will have this word, or will have these basic commands in the system somehow. They will have code in some way to enable the creation, the reading, updating, and deleting of data. So now I wanted to spend some time here, and this may take some time, and so we may have to come back to some of the actual work, the actual playing with some of our code here on Wednesday. But I wanted to spend some time actually installing this MongoDB so that you can have some time to kind of look through this and play around with it when we next come together, or even today. So we're going to be using Docker for this because it's just much more easy to install everything here. And Docker does have this nice Docker, on Docker Hub, the kind folks at Mongo have put together a special Docker container that has everything installed, which makes everything come together. Yes, sir? Sorry? So the question is, should we be, if you're using Windows, should I be doing this in a specific folder? I think that you should not be in the systems folder where you first, or if you're using PowerShell, I don't think you should be in there. I think you may have some trouble. So what I would recommend is that you go into a home directory and you just make a directory someplace and you work from there. But I mean, I don't think anything's gonna be saved there. But I think that if you try and, I think that if you're working in the Windows.system, is that right? I think that problems. I'm not sure. You'll have to let me know if that happens. But I know that I've had this semester I've already had one case of somebody who was working in the systems in the Windows/systems directory with Docker, and it was trying to write Docker was trying to write something in there, and it wasn't working, and so everyone was the software was not working. So I will just do this with you though. Let me just copy this thing here. I think I've already installed this on this machine, but I'm going to just take you through just to kind of get an idea about what to expect. So let me get back to where I was working and get down to my terminal. Give me a moment here to get this thing set up. Start up my terminal. Not that one. This one. You can see this. You see that? Okay. 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 So this is my terminal. I don't think I'll be actually. I'm working in my root here, but I think I might just go into. Well, I'll just work. Here. Just type in cd, then you're good to go. So here I am, pwd. That's my directory, and my first the first thing I'm going to be typing in is this command here called sudo docker pull mongo, which sounds completely unintelligible if you don't know anything about what this command is doing. Sudo docker. Now, if you are using Windows, then you do not need to type in sudo. Sudo means it's your super user. I think actually in your Windows you might want to use the PowerShell. Let's try that first and see whether that makes a difference. My scholars in here will tell me whether PowerShell works. But I think that when I did try this before and I used PowerShell and it seemed to work pretty well. I have not tried the command prompt, and so I worry that perhaps it doesn't work. Okay, so when I go back here, if I type in this command here, I have to, I'll type in my password. And what you're going to see is because I've already installed this, then it just says, pulling everything over and it's all done, blah, blah, blah. That means that I've already installed the software, that my computer contains the latest version of Mongo in a container. That should be good to go. Does anybody else do something different? Okay, so it's all the same. So if you don't see this, what you should see though is like all these different kind of downloads that are happening. Actually, pull over pieces of it. Hopefully, everyone is with me. If it doesn't, If it doesn't work, it could be that there's a problem with your installation of Docker. Work on that. Okay, so I'm going to maybe I'll go back to my slides here, find them, and I'll move on to my next thing. So my next things here, I've put together different commands depending on whether you're using Windows. This is a Windows, first of all. And I'm assuming that you're going to use the PowerShell. So please do use your PowerShell first to try this out. I think that the command prompt should work. See why it wouldn't. I'm not a Windows person, but I think that PowerShell does do the job, and I think that actually PowerShell has the paths involved, whereas sometimes you don't have the global environments isn't established always in. Now, because the machine that I'm working on here is a Mac, I'm not going to be using this, but I can tell you that many of the commands are exactly the same. So, for instance, here in Windows, you have to use this command here, and that creates a space on your hard drive, or a volume as they call it in Docker language. But it's a space where you're going to be able to store your Mongo data. Now, you'll need to have this because it'll be, I'm not exactly sure where that goes. You'll have to find this when you run, for my Windows users, when you run this thing, you'll have to look around for some of the files. It may just be inside of a Docker container, someplace where you don't actually see it as a file in your system. That could also be. So if you find out where these files are actually being stored, I mean, please let me know. Here. Now, the next thing I'm going to be doing, these other commands are all basically the same. I'm going to go to my machine here. If you're using a Linux or a Mac machine, then these commands should be about the same. Now, this command right here that I'm typing in is, rather than actually creating a volume, I'm actually creating a directory in my machine someplace, and this is back to my main directory. And that is going to be the directory that I use to store my database. So in other words, when I'm writing data to my database, it actually translates to writing files. And so those files will be stored somewhere. Those files will be stored here. It's nice to know where these files are, because then if you wanted to back up your database, then you just need to go and back up this directory, and then you've got the database. In Windows, I'm not exactly sure how that happens. If you find out where those files are, I mean, they are there someplace. But presumably, though, that when you find where those files are located, then if you back them up, actually copy them to an external hard drive or put them on the cloud, then you're backing up your database. Oh gosh, you didn't even see what I was doing here. Okay, so so anyway, I need to keep you guys in the dark there. So here I am right here. So I'm going to type in this command here, this make directory Mongo data. So now, I think actually I've already created this directory. I have. In fact, I've already created this data, this directory here, and these are the files that actually fill up. So when I ran this thing last night. When you create this database directory, Mongo data, as you can see, oops, as you can see right here, when you create this thing here and you actually initiate your database, then you start getting all these weird looking files, which are actually kind of, you can see that they're for machine only. Wired Tiger, that's a system, that was I guess it's a retrieval system that's that Mongo is using. It's a technology that Mongo is using. It was written by a company called Wired Tiger. But everything else here, this is what your database looks like. Now, one thing I will say is that one of the big departures from SQLite is that when we were working with a database, we had just one file. But now we have a bunch of files. So it's this does suggest that this is becoming a little bit more sophisticated, a little bit more complicated than a regular system. But the nice thing about this, though, is that you can have multiple people working on this database assuming at the same time, and what's the deal with the file? Okay, so let me go back to our slides. Where are we now? So I'm going to go ahead and start. I'm assuming that your download, if your download is still coming through, if you're at home and your system isn't very, your download speed isn't very fast, that's okay. Just you have all the information you need to have in your slides to get caught up whenever your download finishes. But what I'm going to do now is I'm going to try out this command here. And what this command is going to be doing is actually kind of, the other command that we typed in here, this pull, where was it? this command, the command that we typed in here actually pulls across all the files that we need. It actually kind of establishes the file framework that we'll need to have for our database. Now what we need to do is to actually create or put the files where they're supposed to go and actually kind of order the database and get it ready for us to use. And so that's what this line here does. Sudo docker run it -v. And then over here, this minus v means volume. This is where the files are going to show up. And then inside, this is Docker speak here, but this means that Docker is actually going to be mapping files that it sees here with the files in data./db inside the container. We really don't need to worry too much about what all this stuff is doing, though, but all it's doing is it's saying these files which are outside the container are now these files which are inside the container. A link, not a copy, but a link. Then we have the name, for instance. This is MongoDB. And then we have, this is actually what you're going to be using to call this container Mongo. You can change the names if you want. And I'm going to cross my fingers. I'm going to go back to my container, my terminal, and I'm going to run this to get out of here. And when I go ahead and run this, oh, you know what? I have a conflict. One thing that I have a conflict, and I'm not really sure exactly whether this is the best way of fixing this thing here, but I'm going to do something here, which is, I call this the nuclear option. What I'm going to do is I'm going to take my whole database, I'm going to send it away to some file in temp. I'm going to reestablish my Mongo data, and I'm sure that this is probably not the best way of doing this. If you're actually working with a database, you probably don't want to do this. But this does seem to be a thing here that that I'm trying. What it does is it basically destroys everything that I've done before, and now puts in it, and it actually creates this new working environment. So it's like factory fresh, brand new. There's something I need to figure out, but this seems to be a good way of. So what I'm going to do is I'm going to destroy the old container that I was working with. Apparently the old container is causing problems. And so if I type in this, if I use this command right here, to this rm command, I can remove that old container. Let me just show you what that looks like. Let me go back over here. If I just remove that container, then the problem is gone. If I type in docker, for instance, it's sudo docker ps, I can, oops. Yeah. So this container right here is apparently, it's open and frozen. So if I can get rid of that by typing in sudo docker rm followed by this thing here, and it should be gone. So if I type in this command again, there's nothing there. So really what I'm doing is I'm saying this is an old messy workspace, and I'm getting rid of that old messy workspace so I can reestablish this. The command, though, that if you go back to your slides, this command down here, docker rm $ docker ps a q, that does exactly everything I've just done now, where it destroys the old container information. That does destroy the database, but for now it's okay because we're just working with. If this were a live version, you wouldn't want to do that. So I'm going to go back and try this again and see whether this actually does come up properly. And so let's see, MongoDB is empty. I'll type in this command here, and I run this. There we go. So it ran without problems. So it created a new workspace for me. I know we're 1 more minute here, and I'll see whether so the next thing I need to do now is I can check this. This is a log down here. And by the way, here, one thing that we've just done is that when we ran this command up here, this command actually does establish, it starts up what's called a server. A server is a thing that actually controls or manages the information flow inside your software. And the server is actually now running. This is all information which is being generated by the server. And so I'm now able to see the health of my system. If you go back to your slides, there's a command very similar to this in Windows and here. You can always just type that in and see whether your server is doing anything. One last command I'll type in, sudo docker ps. I can see that something is running. That means my server is up. Shoot. Maybe I'll just try one more thing here, and then we'll break. And that is this last command down here. This will actually take us inside the container. You can see this. This exec, this is like your execute command, which is going to go inside and run this container with our Docker. If I run that, I'm inside. And so now I'm inside my container. You can see that by typing by this root. But also if I type in Mongo, this is my database. So let me just go back to the slides here. I think I'll stop here. But you should be able to get up to this point here, start the MongoDB client. These are all the steps you'd follow here, but you should be able to get to this pink box here with the steps we just run. Now, if you have any trouble with your container, like it's saying that it doesn't want to load it or something like that, you can always just remove the old container with a command similar to this, and then start afresh all over again. Factory fresh. Yeah, I think we're done for this for now. But when we come back on Wednesday, we will talk about we'll go back through these steps again, get you online with your MongoDB, and then we will with some queries and have some fun. Are there any questions? With the root command? Oh, the remove. Yeah, so the RM. So then, if the issue that you have is with the remove command, what I would recommend is this. By the way, to get out of this, you can type in exit. You can type in Docker command here ps aq ps minus a minus q. Oops. Then actually, I have to get out of this first. There we go. Sudo docker minus a minus q. Oh, sorry, ps. There we go. This is the command you need, and then to actually get rid of this, you'd have to type in sudo docker rm, and followed by, you just copy and paste this information. You have to stop it first. You also have to stop this. You have to stop it. If you go back to the slides, there's the command that actually stops right here. If you like type in your stop. I don't mean to keep everyone over time here. Docker. There we go. And then I should be able to run this command. Oh, sorry. Whoops. Yeah. So anyway, what I typed in is this sudo docker stop MongoDB, and then when I typed in this, I knew from this command up here, ps, I knew that this was the value. That was my container value. That's the serial number that it uses. Then I typed in this. But don't worry, we will hit all these things when we come back together on Wednesday. Thank you everyone for staying for staying with me for so long. I do apologize for staying 5 minutes over here. But when we come back on Wednesday, we'll go through the same steps, and then hopefully we'll all be better. Alrighty, everybody, stay well. I'll see you all next time. Thank you.